Hello and welcome to your 15th pre-cal class. I am Mr. Marquez, your favorite online summer school math teacher. So let's get started with today. Today we're going to talk about rational expression. Now, a rational expression is basically anything that can be expressed in the form of a fraction. It can be as simple as a fraction like 1/2 or as complex as a compound fraction. But before we do all that, we want to talk about the domain of a function. The domain of a function is basically determining what possible values x can have, and that's in real layman's terms. So I have these three examples, and I want to know what possible value could this be that would make this true. Now, if I look at the first one, I have a polynomial. And a polynomial, which we've been discussing for the last couple of days now, is an algebraic term that has many expressions. So what number can x be where this is still true? Now, in the case of the polynomials, it's good to note that the domain of the polynomials will always be all real numbers, because technically, no matter what number I write in the x place, I will always get a real answer. So when you see a polynomial, it is always going to be the domain of all real numbers, which means that we would say that the domain, we can say equals all real numbers or capital letter R. It doesn't really matter, okay? So the domain is all real numbers. Now, what about this one? We have the square root of x minus 2. Now, when we talk about radicals, we know, specifically square root, that this can never be negative. So what this is saying is the square root of whatever number x is minus 2. Now, what number can x always be? Well, x can be any number as long as this is not a negative sign. So, for example, I cannot include 0. So I know that inside of a radical sign, it can't have a negative number. So that any possible negative number rules it out. Second, I can't say 1 minus 2, neither can I say 0 minus 2. And this is what I mean. I can't say the square root of 1 minus 2 because 1 minus 2 is negative 1, right? I can't say the square root of 0 minus 2 because 0 minus 2 equals the square root of negative 2. And I cannot determine that. So whenever I have a rational expression, specifically with the square root, I can't have that the number inside be negative. So in this case, I would say that the domain is any number greater than or equal to positive 2. So x has to be any number greater than or equal to positive 2. Now let's look at this. The domain of a rational expression, and here, based on the rational expression, we're going to continue to simplify rational expressions. Now in a rational expression, the denominator can never be 0. So what number could possibly make its denominator a 0? That would be 3. If x equals 3, then I would say 3 minus 2 over 3 minus 3, which would equal 1 over 0, which is undefined. So in this case, we say that our domain is all real numbers, all numbers where x cannot be 3. So basically all numbers except positive 3, right? So that's pretty much how you find the domain of a function, specifically polynomial functions, rational functions, and radical functions and rational functions, okay? So I'm going to go ahead and erase that, and let's talk about simplifying rational expressions. So we already established that a rational expression is any number or any expression that can be in the form of a fraction, okay? So if I look at the formula, I can say, well, a times c over b times c equals ab, and that's what we're going to be doing. We're going to be simplifying. And the formula for simplifying a rational expression is a times c over b times c equals a over b, because these two terms cancel out. Now, if I have this rational expression and I want you to factor it out, what are you supposed to do? Well, we're going to apply all of the concept that we previously discussed in our other videos. Let me take a minute to kind of direction the camera. Hopefully, let me zoom this in real quick. Okay, so We're going to use all the concepts that we learned in our previous videos from factoring polynomials and factoring by, trinomials, special products of binomial, differences of squares, by greatest common factor. We're going to take all that and we're going to apply them into simplifying rational expressions. Okay, so let's talk about how to simplify this expression. Now, like I was mentioning, you need to basically use all the possible forms of factoring that we discussed in our previous section about factoring polynomials in order to simplify this expression. Now, this is what I do. If I have x squared plus 4x minus 12, I need to think of a number, because my leading coefficient is 1, I need to think of a number that when I multiply it equals negative 12, and when I add it equals positive 4. In this case, I would say x minus 2 times x plus 6, because negative 2 plus 6 is positive 4, negative 2 times 6 is negative 12. Now if I look at this one, I can't use the same method because this is a binomial and this one is a trinomial. So what I have to do here is find or look for a common factor between 3 and 6. A number that divides by 3 that also divides by 6, which is 3 itself. So what you're going to do now is you do this imaginary, right? I always say that you don't have to do that step, but it helps a lot. You divide 3 and 3 and they cancel out, and that would leave me with an x. And 6 divided by 3 is 2, which would be x minus 2. And now what I do is I cancel out. Remember this? C and C cancel out. Well, here, the terms that are the same cancel out. Well, x minus 2 and x minus 2 cancel out, which would leave me with x plus 6 over 3. And that, ladies and gentlemen, is how you would factor or simplify your polynomial. Once you've seen this video, once you've reviewed everything, you're going to go to page 42 and you're going to work on problems 7, 11, 19, and 20. And I will see you for your next video lesson, so stay safe.